Hello friends, today's question: three fixed point charges A, B, C of equal magnitude but different polarity are arranged along x-axis. Movable positive charge P is placed along the x-axis at various positions. Charges B and C are positive and negative respectively. The charge A is of equal magnitude but polarity is unknown. Test charge P is positive. The position of A, B and C are fixed along x-axis and P's position can vary along x-axis. When P is at x equal to 2d, the force on P is in positive x direction. So these are the three questions based on this entire discussion. What is the polarity of charge A? Second part, what is the direction of electric force on P at x equal to 6d? And the last is, how does the magnitude of electric force on P compare at x equal to d and x equal to 5d? So this is the basic figure. We have three charges A, B and C. B is positive, C is negative, and the charge of A is unknown, but it is equal, charge is unknown, but it's having equal charge for A as well as B as well as C. And here B is the test positive charge which is movable along this entire x-axis to left as well as to right. So let us solve for the first part, which asks that what is the polarity on charge A. Okay. So we start with part A. And it is said that the P is initially kept at 2d. Okay. So you can say the test charge P is at 2d. The test charge P is at 2d. And it is also mentioned that when P is at 2d, the force on P is acting in x positive direction. So you can say from here that the force on P is positive x direction. So let us redraw the figure and discuss all the forces. So we have, this is our x-axis, and here we have A charge, and we have P, which is a positive charge, and it is 2d, and we have here B, which is at 4d, and we have here C, which is a negative charge and is at 9d. And it is given that the force on P is positive x direction. So this is our x direction. So P is having a force on positive x direction, means in this direction. Okay. So from the figure, we can clearly understand that both B is positive as well as P is positive. So there will be a repulsion force between the two. So let's write this thing. So we say that B is positive, thus repels P because it is also positive. Okay. So because of this, the force of direction will be towards negative x direction. Okay. So from here we can say exerting a force exerting a force in negative x direction. This is your first part, and we have C charge also, and C is a negative, so obviously it is going to attract charge P. So we say that C is negative, thus attracts P, because P is opposite charge that is having positive. And in this case, the force is being exerted is along positive x direction. So you can say exerting force in positive x direction. And it is also said that the net force on P is in positive x direction. And we can say that since net force on P is positive x direction, therefore the force due to charge A should dominate and points towards positive x direction. Therefore, force due to charge A should dominate and point to positive x direction because herein all the charges are same, so obviously charge C is further away from charge P, so its force of attraction, which will be on charge P, will be lesser as compared to charge B. So repulsion force between P and B will be higher as compared to force of attraction between P and C. But the net force on P is in positive x direction, so therefore the force of A should be able to dominate the force of B. Therefore we can say that to exert the force on positive x direction, the charge A must be positive because they are going to repel each other. So we can say to exert a force in positive x direction, that is repel, that is repulsion on P, charge A must be positive. Charge A must be positive. So we found out the polarity of charge A is our positive. And next, what is the direction of electric force at P when it is kept at a distance of x equal to 60? So let us solve part B. Once again, we are going to draw the figure. We have A, and now we have identified it is a positive charge kept at O, and we have B, which is also positive charge, and that is kept at 4D, and we have P, which is also a positive charge and is kept at 60, and then we have C, which is negative charge and kept at 90. And we have to find out the direction of the force, direction of the electric force. So in order to find out the direction of the electric force, let us analyze all the forces with respect to each charge. So we start with A and P. Charge is A, which is a positive, and P, which is also a positive. So therefore, there will be a repulsion force of repulsion in positive x direction. And now we between charge B and P, charge is B, which is a positive charge, and P, which is also a positive charge. So once again there will be a force of repulsion. Force of repulsion in positive x direction. And last is our between P and C. C is negative, P is positive, so there will be a force of attraction. Charge is C, which is negative, and P, which is positive, so we can say force of attraction. In once again positive x direction. So it means the direction of electric field at electric force at P will be in positive x direction when P is at 60. We can say the direction of electric force on P is in positive x direction at x equal to 60. 6D. So therefore we can write that the direction is positive x. And we come to the last part. How does the magnitude of electric force on P compare at x equal to d and x equal to 5d? So we are going to find out the electric force when the charge P is at d and charge P is at 60. So this is our part C. So let us do our first is force at x equal to d. Force at x is equal to d. X equal to d means P is at x equal to d. So we are going to find out what will be the respective distances between all the charges. Let us draw the diagram again. So we have A is our positive, and we have P charge, this is also positive at a distance d, and we have charge at B and its distance is I think 4d. Yeah, it's 4d. And we have charge C, which is negative charge, and that charge is at 90. So respective distances between A and P, the distance is D. Between B and P, the distance is 3D. And between C and P, the distance is 8D. So we say distance between charge P and first charge our A is D, B is our 3D, and C is our 8D. So therefore, the force from each charge on P from each charge on P. So let us first find out for A. For A, we call that as FA, and that will be equal to, because we assume that all these charges are same. We are given the question. Okay, so we are given that A, B, C, they have all same charge, that is equal to Q, and P we assume is equal to P itself. So force is our K multiplied by Q multiplied by P, and it is distance square, and let us call this as F naught. And obviously it is between the positive and positive charge, so it will be repulsive, so we can say positive X direction. Now for B, let us call that FB. FB will be equal to Q P, and this is our 3D whole square, and this will be coming as F naught by 9. And once again, both are positive, repulsion, it will be minus X direction. And last is charge C. So let us call that FC. FC will be KQP, and divided by, we have this 8D whole square, and which comes as F naught divided by 64, and it will be a force of attraction, so it will be positive X direction. Please keep in mind, all these directional forces are with respect to charge P. So therefore, the net force let us call that F net for X equal to D will be equal to FA and minus plus FC minus FB, and now we substitute the values. We get this as F naught plus F naught by 9 minus F naught by 64, and we can just take F naught common and solve this. So it will be coming equal to as 631 divided by 576 times F naught, which is approximately equal to 1.09 times F naught. So we found out the net force because of when the charge is at P charge is at X equal to D. Same calculation we are going to do. Force at X is equal to 5D, and we are also going to find out the distances. So let us draw. So we have A as positive at 0, and we have B as also positive at 4D, and we have P which is now at 5D, and we have C which is a negative charge, that is our at I think 90. So the respective distances, this distance will be coming as 5D, this distance will be our 4D, this will be D, and this distance will be coming as our 4D. So you can say distance between P distances between P and charges at first charge is our A, the distance is our distance is 5D, B, the distance is D, and we have C, the distance is our 4D. Once again we are going to find the forces by using same method. You can say forces from each charge on P, from each charge on P. So we start with A, let us call that Fa prime, that will be equal to K, we have Q multiplied by P, and the distance is our 5D, so this becomes 5D whole square, and which comes as F0 divided by 25, and both are positive, so it will be plus X direction. Now we have second, that is our B. We see the force is Fb prime, which is K QP, and the distance between them is D, so this becomes D square and comes as F0, and this will be our positive X direction. And finally our charge C, which is Fc prime, will be equal to K QP, and the distance between them is 4D whole square, and this comes as F0 divided by 16, and it will be also in plus X direction. Net force, at F prime net, which is at X is equal to 5D, and we can write the values, which is of Fa prime plus Fb prime plus Fc prime. Fa prime plus Fb prime plus Fc prime, because all of them are in X direction, and this is our X. So I can say my F prime net will be equal to, we have our Fa prime is F0 by 25, so this becomes F0 by 25 plus F0 by 16 and plus F0, and if we solve them, it will be coming somewhere around 441 divided by 400 times F0, and approximately equal to 1.10 F naught. So from comparative value, F prime was F was our 1.09 F naught. So we say our F naught was our 1.09 F naught. So if we make a comparison, we can say that our F net prime is greater than our F naught, or we can say the force distance at x equal to 60 is greater than the force at a distance x is equal to d. So this was asked to make a comparison. So this completes the question. Thank you.